All right, let's just dive right into this explainer because we really need to dismantle the PR hype surrounding sodium-ion batteries. I mean, you've definitely seen the headlines, right? The ones claiming this new chemistry is going to revolutionize the energy sector overnight. Well, today we're looking way past all that noise. We're going to dig into the very real industrial, economic, and physical hurdles of actually scaling this technology.
Right now, the market is completely driven by this utopian vision. Sodium-ion is being hyped across the entire industry as the literally ultimate silver bullet to break our dependence on lithium and cobalt. And hey, on the surface, bypassing those incredibly scarce raw materials sounds absolutely amazing. I get it. Literally everyone in the battery, EV, and renewable energy space wants complete supply chain independence. But as we're going to see, the industrial reality on the ground is proving far, far more stubborn than this glossy PR narrative wants you to believe.
So, to get to the actual truth, we're covering 4 key areas today. Number 1, the silver bullet hype. 2, energy density and footprint. 3, the supply chain reality. And 4, 3 critical benchmarks for investors.
Okay, kicking things off with Section 1, the silver bullet hype, and navigating PR versus reality.
Look, the industry is experiencing this massive, glaring disconnect right now. The PR narrative is out there promising this super simple substitution, right? Just an easy bypass of scarce materials like lithium. But talk to the people on the factory floor, and they'll tell you a completely different story. Swapping elements on the periodic table is super easy on paper, but in reality, we are facing incredibly deep manufacturing bottlenecks and a brutally steep adoption curve. You simply can't wave a magic wand and wish away the intense engineering challenges of commercializing a brand new battery chemistry.
Here is the bottom line. We absolutely have to stop viewing sodium-ion as some kind of overnight fix. Achieving true supply chain independence isn't a quick sprint, it is a long, incredibly grueling marathon. The expectation that this new chemistry is just going to seamlessly replace existing tech tomorrow totally ignores the harsh realities of commercializing and scaling advanced materials.
Which brings us nicely to Section 2, energy density and footprint, or essentially the physical limitations we're dealing with.
When you actually compare sodium-ion to highly established chemistries, things like LFP, which is lithium iron phosphate, and NMC, nickel manganese cobalt, a really stark trade-off emerges. Bypassing those scarce materials comes at a major cost, and that cost is significantly lower energy density. Think about it. NMC and LFP have had years and years of relentless refinement to pack massive amounts of energy into really tight spaces. Sodium-ion is currently way less dense, and that results in some major spatial footprint penalties, especially when we start talking about utility-scale stationary storage for renewable energy.
So, what does a drop in energy density actually mean in the real world? Well, it translates directly into a physical footprint penalty. Because sodium-ion holds less energy per square foot, you physically need more batteries. You need more casing, more wiring, and crucially, way more land just to store the exact same amount of power. And if you are planning a massive, utility-scale stationary storage facility, real estate and infrastructure costs matter immensely. It's a huge physical limitation that simply cannot be swept under the rug.
Moving right along to Section 3, the supply chain reality and the massive economic hurdles standing in the way.
You see, scaling this up isn't just about tweaking a few settings at our current factories. It literally requires building an entirely parallel supply chain from the ground up. First, you have to nail down high-volume cathode precursor production, meaning you have to scale the raw materials and the precursor chemicals. Only then can you actually start building new gigafactories from scratch. Because, spoiler alert, you generally can't just reuse existing lithium-ion production lines for this. Conquering both of those massive, sequential hurdles is literally the only path to achieving true supply chain independence.
And because we are starting from scratch, it demands a truly staggering amount of capital expenditure, or CapEx. We are talking about billions and billions of dollars required just to build out this parallel gigafactory supply chain. Sure, the underlying sodium itself might be cheaper than lithium, but the upfront cost to actually process, manufacture, and assemble these brand new batteries at high volume, it's astronomical. Honestly, this economic hurdle is the silent killer of so many of these so-called silver bullet technologies.
Finally, let's hit Section 4, 3 critical benchmarks, which are absolutely essential takeaways for any investors out there.
Okay, before anyone commits serious capital to sodium-ion commercialization, 3 specific benchmarks have got to be rigorously met. First up, pilot economics viability. Can the manufacturer actually produce this stuff at a pilot scale with unit economics that make any financial sense? Second, spatial footprint viability. Have they actually mitigated all those land and infrastructure costs caused by the lower energy density we talked about? And third, CapEx.
Is there a realistic, fully funded roadmap for building out those entirely parallel gigafactories? Without crystal clear answers to these three benchmarks, a project isn't a reality. It's still just operating out there in the realm of hype.
So I want to leave you with this provocative question pulled directly from our sources today, just to challenge what you are actually seeing out there in the industry. Whether you're an investor, a supply chain strategist, or a battery manufacturer yourself, you really have to ask yourself, are you seeing realistic pilot economics for sodium-ion yet? Or is the lower energy density still pricing it completely out of utility-scale footprints? It's the kind of question that forces us to look right past the glossy PR and focus strictly on the hard data of industrial scalability. Definitely keep this question in mind the absolute next time you read a flashy headline about the latest and greatest battery breakthrough.